Hello everyone and welcome to IP Tech Talk. Today we're going to talk about how Wi-Fi drives campus network reconstruction. As discussed in an earlier video, wireless networks were initially used as an extension and supplement to wired networks. But due to the rapid development of wireless networks, many organizations have now started to deploy fully wireless campus networks at scale. So, how does the development and wide use of Wi-Fi affect campus network architectures and technologies? That's what I'll be talking about in this video. First of all, the development of Wi-Fi promotes the in-depth convergence of wired and wireless networks. We can say that wireless and wired networks on campuses have gone through three phases: mutual independence and separation, seemingly converged, and truly converged. Along this evolution roadmap, the campus network architectures changed accordingly, which I already detailed in an earlier video. The second aspect is that the development of Wi-Fi drives the diversity and bandwidth upgrades of wired campus networks. As Wi-Fi standards keep on evolving, the data transmission speed rises from 2 megabits per second to 11 megabits per second, and all the way up to 9.6 gigabits per second in the Wi-Fi 6 era. However, wireless networks in each generation of Wi-Fi need to be carried over wired networks. That's why APs are typically connected to access switches. In this case, if AP's data transmission speeds keep increasing, the forwarding speeds of access switches need to grow. Similarly, the backbone network bandwidth on campuses also needs to be improved. Now, let's look at this figure to see how the traffic models on campus networks evolve. Prior to 2010, the access layer bandwidth of most campus networks remained 1 gigabit per second. And with the increase of Wi-Fi transmission speeds, especially after the advent of Wi-Fi 6 in the recent 2 years, the single stream transmission speeds of APs exceeded 1 gigabit per second. This meant that the transmission speeds of access switches became a bottleneck. To overcome this bottleneck, the access layer bandwidth of campus networks gradually evolved from 1 gigabit per second to 2.5 gigabit per second, 5 gigabit per second, and 10 gigabit per second. You may be thinking that since 1 gigabit per second access layer bandwidth is insufficient, then we can directly upgrade the bandwidth to 10 gigabit per second. So why do we improve the bandwidth of some campus networks to just 2.5 gigabit per second or 5 gigabit per second? This is because although 10 gigabit per second bandwidth is enough for today's requirements, such a high bandwidth is costly and requires recabling. This is because Category 5E twisted pairs usually have been deployed at the early stage of building construction, and these cables cannot handle 10 gigabit per second traffic flow. If Category 6 or higher cables, or even optical fibers are used, recabling needs to be carried out, greatly increasing construction complexity and costs. Given this, the entire industry urgently needed a new solution to improve the network bandwidth without having to reroute cables. A feasible way was to build an Ethernet that flexibly works at speeds between 1 gigabit per second and 10 gigabit per second. It is in this context that the IEEE 802.3bz compliant multi-GE Ethernet was unveiled. In particular, Huawei's latest S5732H series switches are ideal for building such an Ethernet, thanks to their support of multi-GE Ethernet, with 100M, 1000M, 2.5GE, 5GE, and 10GE port rates for flexible choices on demand. These switches are also well suited to transmission bandwidth and power supply requirements of Wi-Fi 6 APs. Now, let's talk about the third aspect, which is how mobile access greatly challenges the deployment of campus service policies. Let's take Huawei's office campuses as an example, which should make it easy to understand. Huawei's campuses have full Wi-Fi coverage. This enables employees to work freely without having to be fixed in one office, allowing them to easily access Huawei's network no matter if they're in a research center, representative office, or production base, hugely boosting their office work efficiency. However, every coin has two sides. This mobile network access mode also poses great challenges to the deployment of campus service policies. On traditional campus networks, access control lists are adopted to control employees' network access permission based on their IP addresses and VLAN IDs. However, in the mobile network access mode, their IP addresses and VLAN IDs will change all the time. To sustain service continuity, network administrators have to reconfigure service policies based on employees' new IP addresses and VLAN IDs every time they move. This creates huge workload for administrators. In addition, frequent service policy reconfiguration is prone to errors, often resulting in employees being unable to access certain resources that they could access before they moved. The result is terrible mobile office experience. To solve this problem, Huawei's campus network team conducted a series of rigorous tests and discovered that the root cause lied in the close coupling relationship between service policies and employee information, such as IP addresses, VLAN IDs, and office locations. As this kind of information keeps changing for employers on the move, service policies need to be adjusted frequently. To ensure service policy consistency, we needed to find an information record that remains unchanged regardless of employees' locations, and use this record as a unique reference for formulating service policies. We realized that identity information, such as the employee ID, could be used. In addition, how to decouple service policies from employees' ID addresses, VLAN IDs, and locations was another top challenge. This is where Huawei's free mobility solution comes in. This solution introduces SDN into campus network management. Specifically, a centralized policy control center is set up on a campus network, so network administrators can centrally formulate service policies in the control center based on employees' IDs, regardless of their IP addresses and network access locations. In addition, network access devices will report employee IDs to the control center. The control center then notifies the network devices of the service policies to be enforced for the employees. This guarantees consistent network access permission, experience, and resources for employees on the move. This is why the solution is called free mobility. Currently, this solution has been deployed at scale on Huawei's campuses, as well as campuses of our enterprise customers around the world. Next, let's move on to the fourth aspect, which is how wireless terminals blur or even eliminate the boundaries of campus networks. This deteriorates the campus network security, and I'll explain it from three perspectives. Firstly, the Wi-Fi network uses radio signals as its transmission medium. It is an open channel environment with no clear boundaries, so terminals can access the Wi-Fi network anywhere. This environment is also at risk of data eavesdropping and tampering. The result is that the Wi-Fi network faces increasingly severe threats, such as signal interference from unauthorized APs and rogue user access. Secondly, BYOD breaks down the trust boundaries of networks that allow access from only controlled terminals. For example, in the past, employees accessed the enterprise network via enterprise-issued PCs, and such PCs were monitored by customized security software. In addition, there were certain corporate rules and regulations for the operations that could be performed on the PCs. Therefore, these PCs were considered trustworthy and controllable. BYOD, however, makes access terminals no longer controllable and trustworthy. This requires a new technology to rebuild trustworthiness of access terminals. Finally, the advent of IoT extends the coverage scope of campus networks from just people to people and IoT devices. However, since security protection for IoT device connections is weaker than that for people-to-people connections, the security issues caused by IoT devices are far greater than those caused by people. To address these security issues, the networks need to provide an extra protection for IoT devices. Now, let's look at the fifth aspect, which is that masses of access terminals strain campus network management and O&M. Firstly, like any other wireless communication system, the Wi-Fi network is a self-interference system, which means that APs may interfere with each other because of their different channel, power, and coverage parameters. This results in cost-intensive and time-consuming deployment and O&M of traditional Wi-Fi networks. Secondly, most O&M teams lack an in-depth understanding of invisible Wi-Fi networks. Once a fault occurs, it is difficult to locate it. In addition, the teams need to continuously monitor and optimize Wi-Fi networks to prevent the network quality from deteriorating due to surging service volumes. This can be a huge challenge for O&M teams with no professional tools. To overcome these challenges, we need to introduce a lineup of game-changing technologies, such as big data and AI, to reconstruct the intelligent campus network O&M system. Well, that brings us to the end of today's IP Tech Talk about challenges brought by Wi-Fi development to the campus network architectures and technologies. To overcome these challenges, Huawei launched a cloud campus solution that integrates an array of cutting-edge technologies, such as wired and wireless convergence, free mobility, big data-powered collaborative network protection, and intelligent network O&M. If you would like to know more about the solution, why not take a look at our book, Campus Network Architectures and Technologies. Thanks for watching, and see you next time.